Assalamualaikum and hi. So this is chapter 6 air conditioning video part 2. In this video I'm going to explain subtopic number 3 air conditioning application. Air conditioning application. Air conditioning applications. The temperature range of air conditioning application is within the minus 10 degrees Celsius to 50 degrees Celsius, and we use atmospheric air, and the atmospheric air is consists of the dry air and also water vapor. And since the temperature range is within minus 10 degrees Celsius to 50 degrees Celsius, the dry air we can consider it as the ideal gas. And since it is an ideal gas, taking the reference of 0 degrees Celsius, we can calculate the enthalpy change of the ideal gas with this equation, which is only looking at the temperature change. And we can calculate the enthalpy with the error less than 0.2% with constant Cp value of 1.005 kilojoule per kg per Kelvin. And for the cases of water vapor, due to the temperature range, we can consider also the water vapor is an ideal gas. So looking at the TV diagram of the water vapor, you can see that this blue line is the saturated liquid line and the saturated vapor line, and the brown line is the constant pressure line, and the red dotted line is the range where the water vapor is considered as an ideal gas, and H here is the constant enthalpy line. The green line is the constant enthalpy line, and from here we can see that the HV, which is the value enthalpy of the water vapor at the ideal gas range, at the superheated range, is the same as the at the Hg value, which is at the saturated vapor line. And since it's close to the ideal gas, we can assume it is close to the ideal gas law. So the enthalpy change of the water vapor we can calculate by using this equation, which only consider the temperature change. And the Cp, which is the specific value of the water vapor, is equal to 1.82 kilojoule per kg dot Kelvin, and we can calculate the enthalpy of this ideal gas of the water vapor is equal to 2500.9 plus 1.82 times the temperature of this water vapor. And since the air condition is a mixture of the dry air and also water vapor, we can use the ideal gas law, which is the PV equal to RT, and the pressure of the atmospheric air or the conditioned air is P equal to P A plus PV, where PA is the pressure of the dry air and PV is the pressure of the water vapor. TS diagram. So as you can see, this is the TS diagram of the water vapor or water. This is the temperature and this is the entropy, which is very referred to as, and this is the temperature. And in this figure also you can see this is the saturated liquid line and this is the saturated vapor line. And since in the air conditioning it operates within the temperature of minus 10 degrees Celsius to 50 degrees Celsius, we can put a line here which is the temperature of 50 degrees Celsius. And since the pressure also within the atmospheric pressure, we can the temperature maximum pressure of the air conditioning system is 1.23 kPa. And let's say we expand this figure. As you can see here, we have this temperature. This is the 50 degrees Celsius temperature, and this is the pressure of 1.23 kPa. And from this figure, you can see that the H, which is the enthalpy of the water vapor at the saturated liquid line, is in a straight line with the superheated region. So this is what I already explained in the previous slide. TS diagram. As you can see, this is the table of temperature saturated with water from the table and the equation. So you can try to use this equation to calculate the enthalpy at this temperature range and see the differences between the data from the table and data from this equation. This is the end of part 2 for chapter 6, and hopefully you enjoy my video.